Hello, welcome back to another episode in the PTX NFC series. In today's video, we will be exploring the RL78 G23 platform. The RL78 G23 are general-purpose 16-bit MCUs from Renesas that are highly suited for low-power applications. It achieves highly efficient low-power operations through the snooze mode sequencer and fast wake-up times. Current consumption can be as little as few hundred nanoamperes on the 4 KB SRAM variants. There are numerous variants starting with 30 pins and going up to 128 pins and 32 MHz operations. The smallest flash memory can be expected to be about 96 KB, while higher variants can go up to 786 KB. And despite these low power operations, these devices offer high-speed on-chip oscillators, low bill of material cost, and a wide variety of peripherals, including capacitive touch. Next, we'll explore how to integrate the PTX SDK with an RL78 G23 device to create a low-power NFC solution. To make the demonstration, we are going to use a PTX-105R Quick Connect NFC peripheral with PMOD connector and a fast prototyping board fitted with RL78 G23 128P MCU. You may already know that these NFC modules can operate on RA devices with OS support. This application note explains how to port the standard NFC SDK originally developed for the RA4M2 to the RL78 G23, which runs without an operating system. Note that this application requires the CCRL compiler. The app note then describes the steps to import the example project and source files that can be built and run on an RL78 G23 evaluation board. For the usage of CCRL compiler, some modification is needed on top of Renesas released SDK. A porting guidance can be found in the link below. The environment for this development would be the E-Square Studio. So let's dive into that process. We'll start by opening an instance of the E-Square Studio. For compatibility, it is preferable to use the latest version. We create a new workspace and click on Import Existing Projects. The SDK is provided in a compress folder, and that needs to be selected in the import window. This SDK has already been ported for the RL78 G23 platform. You can get a copy of it from the Renesas support. We simply click Finish to load the project contents. Once the contents have been loaded, we will open the Smart Configurator file with the extension .scfg. This opens the Smart Configurator perspective, and with it we have access to the pin configuration, board properties, clocks, and system components. This project has already been configured, so we do not need to make any changes to that. The main function is contained within the PTX RL78 IoTRD.c file. We can generate the project contents to make sure all the configuration and APIs are updated. Then we can move to building the project. We will see that there is a compilation error. The error program make not found indicates that the make utility isn't available. In E-Square Studio, check that your compilation toolchain, including its version, is properly configured in the IDE's settings to enable successful builds. So let's try to fix it. First, we will see if the toolchain is correctly configured. We shall navigate to the project properties. Then from the properties window, we shall find the C++ build list and click on settings. From the settings, we shall click on the Toolchain tab. We will notice that the project has been developed for CCRL Toolchain version 1.14. So, we need to have a version that meets these at the least. In our system, we have both 1.13 and 1.15. So, we shall select 1.15. Then we will click on Apply and Close. Now, we shall make our second attempt to build this project. Okay, looks like it's progressing well. And it has built without any errors. Although there are some warnings mainly related to missing paths, incompatible macro redefinitions, and an expired compiler license, they are not critical because the missing paths belong to components unrelated to the RL78 and the evaluation license just works fine for this demo. Next, we will try to navigate to the application file where the PTX entry function is defined. We would like to create a counter variable that detects when a card is read by the NFC. The final user may wish to develop a debug module to produce log messages in a terminal. But as of now, this SDK in its current form does not have a message logging functionality. We're going to place this counter at around line 500 where the deactivation module function is called. Basically, this is the function that is called after every successful card read before the NFC reactivates for the next read event. We will build the project again. Now that we have the software ready, let's get the hardware set up. We will attach the NFC module to the PMOD1 connector of the RL78 G23 FPB device. And then we are going to connect the board to the PC using the provided micro USB to USB-A cable. A green LED will flash once the FPB is powered up. Before we upload the project on the board, we need to double check if the communication ports are correctly configured in eSquare Studio. Since we are using USB connection, we will be uploading the project via a COM port. We click on the Run menu and then Debug Configurations. We shall find the Renesas GDB hardware debug option and navigate to the Debugger tab. We notice that the debug hardware is defined as the COM port for RL78. We further navigate to the connection settings. We shall then select the right port for connection to the target device. In our case, this is COM7. Next, we can proceed to uploading and debugging the project. We can click the debug button from the configuration window. When the uploading has completed, the eSquare Studio will prompt to change the perspective. We click Switch to change to the debug perspective. Then we would click on the resume icon once to open the main function. Before we execute the main function, we are going to use the expressions tab on the right to monitor the card read variable. We can simply drag the word card read into the expressions tab. E-Square Studio will detect its data type, current value, and memory address. We will also enable real-time refresh, so the updated value is displayed during the process. Now we can press the Resume button again. Notice that the value has been set to 0, the initial value that we set for this variable in our program. When we take a sample card close to the NFC module, the value will change. This means the NFC read functions have been activated and deactivated 10 times. We remove the card and place it back, observing a further increase in the card read counter. And it keeps running. We can stop the program now. So, those were the steps to get the example NFC reader application running on an RL78 G23 board in E-Square Studio. We can build a complete application based on this implementation. See you in the next episode.